When designing the component parts of assemblies, engineers frequently face product development demands that often lead them to rethink how parts might need to be designed and manufactured. Traditionally, an assembly component might be manufactured through moulding, casting, or maybe via a process of machining from billet to achieve the desired shape. But what if the requirement was for the same mechanical function and equivalent mounting size, but with a reduction in component weight or consolidation of assembled parts? Even the most capable of design engineers will be limited in the number of possible design iterations they can produce in a given time. Generative design changes this. Combining artificial intelligence with cloud-based computing, generative design uses goals and parameters such as materials, loads, manufacturing methods, and cost constraints to design your parts. Unlike topology optimization, generative design explores hundreds or even thousands of possible permutations of a solution, testing and learning from each iteration what works and what doesn't. Successful design alternatives are quickly presented where the ideal optimized design, which caters for the desired method of production, such as 2D machining or 3D metal additive printing, and can be chosen and sent out to be manufactured. If the critical requirement is to reach the minimal weight of a component, for example to reduce the energy required to rotate a mechanism, then 3D metal additive printing might be the best solution. Additive manufacturing can be used to produce parts that would be difficult to manufacture conventionally, with the option to replace solid structures with strong, lightweight, hollow components containing internal latticing. The additive build can be simulated to predict any issues, before models are sliced with the 2D toolpaths necessary to control the laser to print the part. Printed parts can then be quickly and easily machined for accurate final finishing. In this example, you saw Autodesk Inventor for the CAD design and assembly modelling, and Autodesk Fusion 360 for the cloud-based generative design. Autodesk NetFab for the additive print simulation and manufacture, and Autodesk PowerMill for the toolpath creation and machining. So whether you're looking for additive or subtractive processes, or a hybrid of the two, standardizing on Autodesk technology will help you to make anything.